To solve the first system, we're going to need to start by getting the x and y intercepts for the second equation. So if we let y equals 0, we can say 2x equals 8, so x equals 4. And if we let x equals 0, we can say 4y equals 8, so y equals 2. So I can see that I've got an x-intercept of 4 and a y-intercept of 2. If I look at that, that's going down 2 and right 4. So down 2 and right 4 would reduce to a slope of -1/2. So that'll let me put in a few more points to get this line to go accurately all the way across the graphing space. Then I can go back and I can graph the original line. The original line started at a y-intercept of 2, and it has a slope of down 1, right 2. And as I start graphing this, I'm like, wait, this is the line I already graphed. So this is a situation of infinitely many solutions. Every single point on the first line is also on the second line. They share all of those points, so there are infinitely many points in common. I'm going to label a couple of points on my graph because we always label 2 points on every line, but that's all I need to label. We want to remember that neither of those points I labeled is the solution. They're just 2 of the infinitely many solutions. So it is important that we write infinitely many solutions down below. In question 2, we've got a point slope equation to start with. So we can see that that's going to go through the point -1, +3, and that we will have a slope of 2. So I'm going to start at -1, +3. I'm going to go up 2, right 1, and down 2, left 1 to get all the way across the grid. And then for the second line, I see if I try to just set each thing equal to 0, I'm just going to get like the one intercept. That's not going to be enough to graph from. So I'm going to go ahead and solve this for y. If I subtract 6x from each side, I get -3y equals -6x. And if I divide that by -3, I've got y equals 2x. So I can see that my slope is 2. I'm going up 2 and over 1. So I'm realizing that's the same slope as the last line I graphed, but I am graphing a distinct line. So this is not infinitely many solutions. This is no solution. These 2 lines will never meet. So there's no solution to this system. So we're starting out with our 2 special cases. Example 3 is 2 point slopes. So we've got -2, +4 with a slope of 3. And we've got -5, +5 with a slope of -2 for our second line. So graphing the second one, I go to -5, +5. That's way up here. And I'm going down 2 and right 1 all the way across the grid. And then for the other one, I'm starting at +3. I'm starting at -2, +4, and I'm going up 3, right 1, which immediately takes me off the graph. So I'm going to turn around and go down 3, left 1, and I can see that I will run into that other line. So I'm going to go ahead and label -2, 4. I'm going to label the point of intersection. That always should be labeled on a graph. And I'm just going to pick one other point, maybe 0, -5. So my solution to the system is that one point where they meet. So the solution is the point -3, 1. In number 4, we start with a y-intercept of 0, 4 and a slope of -1/3. And then we have an absolute value. So we can have systems that also involve absolute value graphs. So remember from our work in Unit 6, this absolute value is going to have a vertex of 3, -1, because there's nothing written out here. We've got a slope of plus or -1. So this is a normal opening up V. So I'm going to go over to 3 and down to -1, and I'm going to run my slope. Actually, this is unfortunate because I can't see that intersection on the graph. The way this grid is drawn, we actually can't see the intersection, so that's an unfortunate failing of this grid. But we can see that if we extended this down 1 and over 3, that's actually the point where they would meet. For the other side of the absolute value, it's going to come up this way, and we just barely meet up here on the top of the graph. So I'm going to put my absolute value in, making sure to draw my arrows on the ends. I'm going to go back and put the line back in with its extension. And we can see that they're going to meet way over here off the graph. So that's 2, 4, 6, 2. And we can see that they also meet over here at -3, 5. So this is a little bit different than when we had two lines meeting. We now have a line running into an absolute value, which opens up some more possibilities. This system actually has two solutions instead of just one solution like a line meeting another line would have. Do make sure to label your vertex at 3, -1. We've already got 2 points labeled on that line with those 2 intersection points, and let's just grab a couple of other labels on our absolute value graph. Looking at problem number 5, we have another slope-intercept equation. So we've got a slope of -1 and a y-intercept of 1. So we graph the point 0, 1 and go down 1 over 1 all the way across the graph. You never know where these things are going to intersect, like that last one we just saw where it actually intersected right off the grid that we have. So you don't want to shortchange your lines and go only a little bit across. And then we have another absolute value. Notice with this negative out here, that absolute value is going to be upside down, but it's still going to have a slope of plus or minus 1 because there isn't any other number besides that negative. We can see that our vertex is going to be at -2, +7, which again is unfortunately off this grid. So these grids are not sized very well for these two particular problems. I'm going to go back and add a bigger grid so that you can see a good graph, and then I'll restart making this graph. So I've added a bigger grid and have put the line back on it now that there's more space, and let's go ahead and graph that absolute value. So the absolute value starts at -2, +7, and has a slope of 1 and -1, but this time I want to let them open so that they go upside down. Now this is interesting because this absolute value graph looks quite a bit different than the other one. Notice in the other absolute value graph, the line intersected the absolute value sort of on each branch. But look what happens with this one. Since our line had a slope of -1 and one side of our absolute value has a slope of -1, those two parts never meet. So just like when two lines meet, this absolute value and line system actually only have one solution. So let's figure out what that solution is. It looks like they're meeting at -4, +5. So that's our one solution to this system. And then as always, I'm going to label a few other points on my graph so that it's really easy for somebody looking at my graph to see what's going on. And I am going to need to label an extra point on that line because since there was only one intersection, I only had one line labeled.